Hello everybody. Now we're going to talk about the second part of the course, which is the convection or convective mass transfer. And convection mass transfer is the second mode of mass transfer after the molecular diffusion. And in this part of the course, we will discuss what we mean by mass transfer by convection and the equations that describe the convection and the types of convection or convective mass transfer. But in this video, I would like to make it as an introduction where I will highlight the main differences between convection and molecular diffusion and why it's important to understand this difference because it's a really important point. So to understand this difference, let's watch this video. This is like a simple video. We have here 2 cups full of water, the same amount of water, the same shape of the cup, and we have this food color where we put a few drops of food color in both. And you see now mass transfer is taking place by molecular diffusion here. It's only there is no other cause of mass transfer, but just the concentration difference. And you see it's taking some time to get the concentration homogeneous. But once we mix or stir the cup to the right, the mass transfer is done. So this is what this cup will eventually look like after a day or two, where mass transfer is going to take place very slowly until it reaches the homogeneous concentration everywhere in the cup. But the very short or very small stirring that we applied to this cup was enough to finalize this mass transfer in few moments, and it just took maybe a second or two to get this homogeneous concentration here, which would take a lot of time if you depend on the molecular diffusion. So what we did is apply force on the fluid, increase the turbulence of the system, and this is what makes mass transfer faster. And this is convection. So this is the main difference between molecular diffusion and convection. And this is something that we see in both heat and mass transfer. And this is one thing that I would be very interested in, especially in this convection part, which is the analogies between heat transfer and mass transfer, because the mechanism of heat and mass transfer in convection is very, very, very close, and this reflects in the equations and reflects in many things, and this is something I would be visiting a lot in this chapter and the coming chapters to highlight the similarities between heat and mass transfer. So for instance, here in case of convection, heat and mass transfer, this is something that we do a lot. We do this for cooling the food. If you want to eat something, a soup or any other food that is very, very hot, then you cannot eat it, and then you want to cool it down. So one thing that you just blow in the food, and by blowing you are increasing the rate of heat transfer, and this is convection. If you leave the soap for like an hour, its temperature would gonna go low, but you want to make it quick and cool it down quickly, and this is why you apply some force. You increase the turbulence on the soap. The same here if you have a cup of coffee or tea and then you want to like add some sugar, then you stir it to make it quicker. The same thing we can see it in other case where we don't apply mechanical force by ourselves, but it's due to the difference in densities. So if the fluid contains 2 regions where the densities are different, then you would see that the fluid will move by itself without applying any external force. And this is something that you can see very, very clearly if you have like a cup of water or like any container filled with water, and it's getting heated, and you'd see that there is some motion in the water. You can see it if you put some like pepper or any other powder in water. You'd see that it's moving around because of this turbulence. The same can be noticed here in this video in the bottom. where we have a hot cup of water and a cold cup of water. This is the cold cup of water, and you'd see its diffusion is very slow. But if you do this for the hot cup of water, you would see that the temperature or the high temperature increases the rate of mass transfer. The particles of water have kinetic energy, and this kinetic energy makes them move quicker, and this motion will lead to the increase in the rate of mass transfer. So it seems that there is some difference between mass transfer in this case and in this case. Here we apply external force, and here we just depend on the difference in densities, which make it another, or they're both convection, but it's not the same thing. So to differentiate between them, we have what we call the natural convection and the forced convection. These are the main two types of convection. For natural convection, I think this video is a very, very nice video that will demonstrate it clearly. So this is like all these videos have the YouTube links here. You can visit them if you are interested. And in this video, this is a tub full of water, and or a sink. I'm sorry, it's a sink full of water, and this basket here, or this bucket, is filled with, or there is some dry ice. Dry ice is simply solid carbon dioxide, and its temperature is very, very low. I think it's less than negative 100 degrees Celsius, so it's very, very cold. And then he is gonna put it here in this water, which is very hot relative to the temperature of the dry ice. The dry ice will evaporate and will produce carbon dioxide vapor, which is a very dense vapor. It has high molecular weight and its temperature is higher, and this difference in densities is what make it, the difference in densities between carbon dioxide and water is what make it transfer from a place to another, just due to the difference in densities. And this is what we will see here. So you'll see it's giving out some or producing some vapors, but once it's put in water, the rate of producing of vapors is a lot. And this is what I want you to notice, that there is something like a waterfall here. It's actually a carbon dioxide fall. It's not waterfall. This motion, there is a very, very quick motion. There is turbulence in the system, and this is only due to the difference in densities. This difference in densities here is because of the difference in temperature and molecular weight. It can be due to difference in concentration or any other thing, but this is what we see here. This is getting, or it's a very long video. It's taking, I think, like 10 minutes or so, but it's a very, very clear phenomenon here, that you can see that the motion of carbon dioxide vapors is only due to the difference in densities. And this is like a long video. You can see more details about this video, or the full video in this link. But the point I want to make from this is the difference in densities is causing this convection, which we call natural convection. There is what we call a forced convection, which is due to the mixing. So as we see in this mixing tank here, it's a viscous oil, and due to the mixing, you can see the two fluids are getting mixed together well. The concentration is getting more homogeneous due to the application of external force, which is forced convection. This is something that is very important in daily life, and it's very important in industry as well, because in all the mass transfer processes, it's very important for us to enhance the rate of mass transfer and to increase it as much as we can, so that we can get better separation, we can improve the efficiency of the process, and this will make the cost of the equipment and the operation lower than doing this with slow mass transfer rate. So one example here is for gas liquid contact operations, for tray columns. So in the tray column, you have a tray with holes in it where a gas is bubbling in a liquid that's on the surface. So the design is made so that we have
shows an optimum behavior.
So that we have a lot of bubbles, and as you see here, the bubbles are coming out from the liquid surface at like a high velocity, and this velocity increases the turbulence in the system, and this makes or creates a lot of bubbles, which is the area of mass transfer, as you see here, and it increases the turbulence in the system, so you increase the rate of mass transfer. This is something that is made intentionally or designed intentionally to enhance the rate of mass transfer. Without this, the rate would be very, very, very slow, and that's why in such cases you have what we call the operating or the optimum operating ranges, where you have a velocity that you cannot get lower or you cannot exceed it, so that you have or velocity range, so that the operation is efficient. The second case here is the case of liquid extraction. So in liquid extraction, I'm sorry. In case of liquid extraction, this is like a process where we extract one component in a liquid phase using another liquid that is immiscible with it. So the two liquids have two different densities. So one liquid goes from up to down and the other from down to up. But the point is to increase the turbulence and to increase the rate of mass transfer. And one design is what we see here, that we have trays which are movable. They move up and down to mix them well, to increase the turbulence, to make sure that everything is in motion, and consequently the rate of mass transfer is higher. So you can see this is a big part of the design, is to ensure that convection is taking place efficiently, and you are increasing the convection mass transfer as much as you can. This is also the case in other or other equipment for mass transfer, like the mixing tanks, like the solid liquid extraction, and many other equipment. And even in heat transfer, the design of heat transfer equipment, like the heat exchangers, is based on or part of it is based on the turbulence. The baffles that you have is meant to increase the turbulence inside the shell side, and so on. So I would like to make it clear that convection is the mechanism of mass transfer and of heat transfer that gives us some control on the two phenomena, and will allow us to increase the rate as much as we can. And without it, you can imagine if life is only dependent on molecular diffusion or on heat transfer by conduction, life would be very, very, very slow. So this is a very, very important concept that has to be very clear in our minds, and that's it. So in the next videos we'll see the equations and how we can describe it mathematically. So this is gonna be the topic of next time. So I'll see you then. Goodbye.